Hi, everyone. This is Jarrett Hartman from Tech San Diego. I'm the University Talent Director for Tech San Diego. We're still on track to start at 3. We're going to give people a few more minutes to just kind of uh, get into the room and get all set up. So just give us a few more minutes and we'll get started. Thanks.
Great.
Hi, everyone. I've seen a few more people come into the room, so I just wanted to say we're just waiting a few more minutes, just letting a few more people come into the room, and then we'll start the event. Thanks for coming. Okay, we'll just start kind of getting started and do a little brief introduction. Again, my name is Jarrett Hartman. I'm the University Talent Director for Tech San Diego. We're very happy to be partnering with DS3 for this event. Before we get started, I just wanted to kind of introduce our presenter and say a few things about Tech San Diego and today's event. Tech San Diego is a nonprofit that works with small to mid-sized companies here in the San Diego region. My job as University Talent Director is really to make sure students know about opportunities available in our local tech ecosystem, like internships and job postings. And you can actually view a comprehensive list of San Diego's tech companies, including those who are hiring, in our regional tech directory at techsandiego.org. If you have any ideas for events or topics that you would like to hear about on kind of features like our podcast, please reach out to me at jarett.hartman@techsd.org, and we can go from there. I've been working with Shruti, Sravya, and Catherine, and others from DS3 throughout the school year, and I'm really excited to keep working with you all going forward into the fall and into next year. With that out of the way, I'd just like to do a very brief introduction and say hello to Chris Smith, Senior Data Scientist from Teradata. Go ahead, Chris, take it away.
Thanks, Jarrett. Yeah, I want to thank Jarrett and Sarah Spiva, who's also here, and everyone at Tech San Diego who's organized this, and also DS3 as well for giving me the opportunity to speak today about a day in my life as a data scientist at Teradata. So I have some slides I'm going to go through at the beginning. I don't think it's going to take that long. We'll have plenty of time for Q&A at the end. So what I'm going to cover is a little bit about who I am and my background, a little bit about the company I work for, which is Teradata, and then I'm going to say a little bit about what I do at Teradata, and then I'm going to talk a little bit about the specific sorts of experiences I have day to day to kind of fit with the theme of day in the life in my job at Teradata. And then I'll just wrap up with a few observations about the the nature of being a data scientist in industry, which is probably what a lot of the attendees are interested in if they're a part of this organization and here at this talk. So first of all, about me, well, I have kind of a general statement about data science at the top of this slide, which is that from my experience, just being in the profession, working with other people, going to conferences, it's a very high variance profession in at least two respects. First, how people get into that profession. They come from lots of different backgrounds and follow lots of different paths to get there. And then when they are in data science jobs, the jobs themselves vary a lot. And you might have two jobs that are both, not atypical data science jobs. They're still very, very different from each other in terms of what you do day to day. So throughout this talk, throughout the course of this talk, that's just something I'd like everyone to keep in mind. That I'm kind of giving you one data point about what it's like to be a data scientist in one job at one place. But if you're really interested in learning about what that experience is like, you want to really ideally collect lots of data points from different people and hear from other speakers and other data scientists and have other data scientists share their experience. I really illustrate the point that the profession is high variance with regard to how people get here, because I did not follow a traditional path at all to get into data science. By the way, my title is Senior Data Scientist at Teradata right now, and I'll get more specifically into what I do a little later. So my background, I got my bachelor's degree. I double majored in math and philosophy at Vanderbilt University. And then I decided to pursue philosophy further, and I got a PhD in philosophy from the University of North Carolina at Chapel Hill. And I was centered in North Carolina for about 12 years. I taught philosophy for several years at UNC Chapel Hill and a number of different universities, but then decided I wanted to do something different and something more related to math. And so I got a master's degree in analytics from North Carolina State University, which is very close to UNC Chapel Hill, and went into an actual data science job in 2016 at Teradata. So I've been at Teradata now almost 4 years. I know a lot of you may or may not know much about the company, so I'll just give you a little bit of basic information about Teradata. It's a pretty well-established technology company. It was founded in 1979, so we're now a little over 40 years old. The headquarters is in right here in San Diego, in the northern part of the city. Rancho Bernardo is the community we're in. It's got about 10,000 employees worldwide, and our main customers that buy our product are large businesses that have very, very, very large amounts of data they need to store and manage and process. Traditionally, the main product that Teradata has produced, going back to the early years, are data warehouse systems that store very, very, very large amounts of data and also are very efficient at processing that data very quickly through massively parallel processing. That's kind of the linchpin of Teradata's product architecture. It divides data out across lots of different storage units and processors, and it can service SQL queries or other types of analytic processing against the data really, really rapidly and efficiently. So I included a little picture here just to give you a visual image. Teradata nowadays is a very diverse offering. We offer sort of like on-site hardware that companies can buy and use, like these big data cabinets you see here in a data center somewhere. This is just some picture I grabbed from Google image search. That's our traditional offering, but now we have lots of cloud offerings and as a service type offerings as well, where people can subscribe and do things over the internet and things like that. But this is like the traditional thing that Teradata has offered, these big tall cabinets that they might be like, I don't know, 5 feet tall or something like that. And, each of those cabinets is just packed full of servers, which are basically computers, and like external hard drives, all wired together in a big rack. And then those hard drives can store huge amounts of data, and then everything is wired together, and people access that over a network, and those cabinets can process SQL queries or other types of code that needs to use the data and return results really, really quickly to users. Now, let me talk about what I do at Teradata. So I'm currently in the company's customer service division. I'm on a team of around 10 people. It kind of fluctuates a little bit, but about 10 people is the size of the team. And it's mostly composed of data scientists like myself and software engineers. And then there's also like a product owner who's kind of the business person overseeing the team and so forth. And what my team does is develop a product called Service Analytics Machine, or SAM. I call it a product, but it's really like an internal tool that Teradata uses to try to automate its customer service operations and make them more efficient. So I included some bullets here in the middle of this slide just to give you like the really 10,000-foot overview of what SAM is all about. We have a lot of customers. They buy our products, like any kind of product. They have problems, concerns. Maybe their system is running slow, or it's giving some kind of error message or something. And so they tell us about it, and they want our help with it through our customer service. And when they do that, it generates what we call customer service incidents, which are like work items that go into a system, and they're tracked, and people are trying to resolve them as quickly as possible and so forth to provide a good experience for our customers. A lot of incidents, it's been known for a long time, are known issues, which means the customer contacts us and they say, hey, I've got this problem, help me resolve it. And then we look into it, and, oh, well, this is something that other customers have had on and off for years, and we sort of know about it already. And as you can imagine, some inefficiency can arise, kind of solving the same problem over and over again. So we have these little publications that we manage internally called knowledge articles collected in a knowledge base, where the customer service department sort of writes up descriptions of common problems and how to solve them and so forth. So traditionally, our customer support representatives, the actual the main sort of employees in the customer service division, they manually resolve customer service incidents. And part of that is trying to look through knowledge articles and see, is this a known issue, and a new incident is created that we can solve by just pointing somebody to this knowledge article. And so SAM, the product I work on, tries to automatically identify knowledge articles to resolve known issues, so that when the same problem comes in for the 50th time or something, we don't have to have a person deal with it at all. It's just kind of detected, this is something we've seen before, and this knowledge article is the solution, and we just kind of send the customer that knowledge article, and that kind of resolves it. So that's the idea of SAM, to save effort by automatically resolving known issues among our customer service incidents. I've only been on this team working with SAM for about a year, and previously I worked on a different team, also in Teradata, that did something somewhat different. We took customer system log data, which is like the customer has their system. It's this big cabinet with all these computers and hard drives wired together, and it's sitting there running all the time. And there's processes within that system that every 10 minutes or so will write out data saying, the system used this much of its CPU capacity or this much of its IO capacity or something in the past 10 minutes. And then this log data sort of builds up and up and up. And a lot of times that's used to kind of get down into the details and try to diagnose system problems and so forth when customers have problems. And so a team I worked on previously that I won't talk about as much unless somebody wants to ask, tried to analyze that data and automatically detect anomalies in the log data or problems that we might be able to help the customer solve quickly. All right, now the title of the talk is Day in the Life of a Teradata Data Scientist. So, so I'm going to try to talk a little more concretely about my actual sort of day-to-day experience here. And, anybody working in most any kind of technology job or even lots of other kind of jobs, really, when you get down to it, they spend their life looking at a screen and looking at different sorts of applications and websites and so forth on a screen and interacting with them. Whether you're stuck at home due to a pandemic or whether you're going into an office, regardless, that's what you're looking at most of the time. So mostly I just went through and took screenshots of some of the main tools that I use day to day, because I think this actually is the best indicator of what I actually experience day to day. As on some of these, as you can already see here, I sort of blacked out things at the advice of legal counsel that might identify things that we prefer not to have identified, but those don't really get in the way of understanding. So I'm just going to walk through some different screenshots, kind of showing different aspects of what my job is all about day to day. So the sort of starting point for me most days is the thing you see here, which is a Scrum board. So like a lot of technology companies, Teradata, or not all of Teradata, because it's a big diverse company, but a lot of teams and groups within Teradata follow a management practice called Agile or Scrum, which is more specific. And then we use a tool called Jira, which is what you're looking at here, to organize that work. And you can look at, if you haven't heard of Agile, you can look it up and read all about it. But basically, your work is sort of organized into work tickets that you sort of plan out every 2 weeks and then frequently sort of revisit and discuss and revise. But during the course of a 2-week period, which is called a sprint, you have these various work tickets and you sort of you work on them, and as they proceed, you move them sort of from left to right across this board to show the state of progress. So this is not very there's not a lot interesting going on here, but if you look at the sort of towards the bottom, you see 4 sort of rectangles that have kind of a little red circle with a guy in them. And those are like my tickets that I have right now in the current sprint. And you can see 2 are in progress and 2 are to do. And there's also columns for other statuses like in review and test, which I don't have any examples of right now. And then at the top are a couple that I helped other people close out. So those show up as well. But this is kind of like where most of my days start is by looking at what tickets I have and planning out, how can I move some of these across the Scrum board. Another big aspect of my job is meetings, being in meetings and engaging in lots and lots of verbal communication. This is not the team I work on. This is just some generic screen image I got off of Google image search. Nowadays, this is what the meetings look like, as I'm sure you can imagine. Back in the before times when we were allowed to actually leave home, we gather around a table with a big screen, or maybe go into a conference room with a big screen, and then basically go through the Scrum board together, at least for the main recurring meeting, which is the daily stand-up, which is another part of Scrum, where it's about 30 minutes every day, and everyone meets and you talk about your tickets and just make sure everyone's on the same page and on track with what they're doing. But in my job, and I think probably most data scientists' jobs, meetings and verbal communication are a big part of the job. You got to constantly be asking people to help you understand the data you're working with and understand what they want you to do with the data, and communicating out what you're seeing and how they'd like you to proceed based on what you see and so forth. And so you can't get away from communication as a huge part of the job in data science. So here's the good stuff. Coding and analysis, as you'd expect, is a big part of a data scientist's job. probably for a lot of students, this might be the main or only thing they think about as being part of the job. I guess I'd like to emphasize that this is only one part of it, and the other things I'm showing are also really big. But here is the main thing you'd think of as being part of a data scientist's job is writing code, interacting with data, and doing analysis. In my job, the main tools we use are SQL for interacting with a database. Python is the main procedural language we use, and we write Python a lot in a sort of traditional IDE environment. We use PyCharm, but then the data scientists like myself use Jupyter notebooks a lot. I don't know anyone's background who's listening, so I'm just kind of explaining things. This might be old hat or not, but I use Jupyter notebooks a lot. They're really, really great. They're a tool for you can write Python code, you can execute it, and they sort of package up the code and the output and documentation as well, which you can put in there with Markdown, all into one single package that's easy to then share and show people and so forth. And so this is just one screen capture from one thing I was doing a while back with some decision trees or something like that. And this is what I spend a lot of time looking at in my job day to day. And this is what I like about the job. And this is what people imagine you do a lot of times. So it's really great, coding and analysis. Testing. So it's there's as I said, the team consists of data scientists and software engineers, and the team generally, kind of at a high level, I think it's viewed as a software engineering team where there's software engineers kind of building a lot of the main components that operate day to day to receive customer service incidents and determine the solution and all that stuff I talked about. And then the data scientists are kind of designing the core sort of algorithm. But everybody on the team spends a lot of time with software engineering practices and protocols and so forth. And a big part of that is software testing, and the main tool we use is a service called Jenkins for that. Basically, for people who might not be familiar, when you're developing a software product in a sort of contemporary tech company sort of environment, you have sort of one code base that everyone on the team is sort of contributing to all the time. And whenever you have the task of writing some new code to add into that code base, you can't just shove it in and have that be in the product. You've got to make sure that it works and that it integrates well with all the other code. It doesn't cause problems. And so there's a large testing apparatus in place to keep everything in order in that regard. So this screenshot just shows sort of the internals of how we do testing. From this, I don't even remember what project this was, but I wrote some code and I ran it through our testing apparatus. And this sort of shows, if you kind of imagine reading it from left to right, the code, I sent the code into Jenkins, and Jenkins took it and kind of like put it together with all the other code in the code base and kind of ran it. And it kind of split the processing across all these different streams, which are all those parallel lines you see across there. And there's all these different collections of tests that it has to pass. And I did a good job on this one because you see green check marks everywhere. So, it passed all the tests, which means that the code I wrote got to go into the final product that we use and we push out to the world. And then there's some empty ones because it skips certain ones for certain reasons and so forth. But this is a big part of your life when you're working in a software development environment. And then also related to that is version control and Git and GitHub. So in addition to running your tests to make sure that your code doesn't break anything, there's also a whole process around actually merging new code you write into a larger sort of code base and keeping track of changes over time. So if later you found out you subtly broke something, you can sort of revert and roll back and all that. And all that's controlled by our version control system, which is Git and GitHub, which is probably the most popular one out there. So there's a whole process when you want to merge new code that you wrote into the team central code base of creating a branch on GitHub, and then when you're done, you create a pull request, which is what I have here, and then you ask someone else on your team to review your pull request and approve it and merge in. And so this is another big part of the job day to day. And then the last one I'll talk about with regard to my experience day to day is documentation and written communication. So just like verbal communication is really important, you have to be constantly talking to people about what you're doing with the data and about your analysis and so forth. Documentation and written communication is extremely important as well. You have to when you finish some kind of major project or analysis or even reach important milestones along the way, you have to have results and explanations written up in some kind of stable place that you can conveniently point people to go and read about what you did, because you can't be constantly having meetings to explain the same things over and over and over again. So the tool we use for that mainly is just a wiki, which is the product is called Confluence, and it's put out by the same company that makes Jira, and this is kind of what it looks like. And so I spend lots and lots of time showing and explaining results of analysis I did for people to read, to keep up with what I'm doing day to day. So let me wrap up. This is my last slide with just some observations about being a data scientist in industry. The first one is one I said at the beginning, but I just wanted to repeat. Data science is a high variance profession. You would be a big mistake to listen to any one person with experience in this profession like myself and think that's all you need. That gives you a full and representative picture of what being a data scientist is like. If you're interested in learning about this kind of experience, you really want to hear from as many different people as you can. There's a lot of variety in how people get here, and then what they do when they're here. So a lot of these experiences I talked about with testing and version control and Scrum and all these kind of things. A lot of other people have data science jobs that are also very typical and don't do any of those things at all, or do them very, very differently. So there's just a lot of variety, and I would encourage anyone who's interested in sort of learning about this type of role to get a lot of different voices. With regard to, in my experience, the nature of the work and what it's really like at a high level, I find the essence of my job often is mediating between two different things that don't always click naturally and easily. So one thing is business and manager types of people, like actual managers or like product owners or things like that, who are in the business you work in but don't have data science experience. And these people often know a lot about the data you're working with, which is often very, very complicated data. If you just work on sort of simple data sets or school assignments and things like that, you really sometimes don't appreciate how incredibly complicated data sets are in real businesses in the world, where you have dozens of interrelated tables and some of them have hundreds of columns, and they have observations that have been built up for years and years and years. And the people in the businesses you work with, they'll often know these data sets very well. I know what's in them and what the columns mean and their history behind them and all this kind of stuff and the business significance. And if you just come into a job, you don't know any of that. It's sort of overwhelming. So you have to be talking to these people constantly to understand what the data means. They know a lot about what the data means, and they often have a lot of ideas, at least if they're the ones kind of supervising you, a lot of ideas for things they want to do with the data. Like, oh, I think we could look at it this way or that way, or build something that tries to do this or that. That they really like the idea of, they want to try out. They feel like vaguely, data scientists seem like the right kind of person to do this. Maybe the ideas are kind of vague sometimes. So people in that kind of situation, they know a lot about complicated data sets, and they have lots of ideas that are good but maybe kind of vague, or one of the two things you're mediating between. And then the other one on the other side is sort of what you learn in school. All these academic techniques for modeling, clustering, machine learning, optimization algorithms, statistical inference, all these academic techniques that you learn, and you sort of know from your training, oh, this is what you do as a data scientist, right? You have some predictor variables, you have response variables, you try different types of models, you try a linear regression, you try a decision tree, et cetera, and find the best one, and you use these metrics to evaluate it. You have all these techniques, you know them, but when you're dealing with the business and manager types and these complicated data sets, you find that the techniques often aren't quite designed for data sets as complicated as you actually encounter, right? It's not quite clear what even should be considered an observation or a feature or a response, and you have to think through those kind of things. It's not obvious, and oftentimes the techniques don't quite match any of the ideas that the business or manager types have for what they'd like to see you do with the data, right? They don't think in terms of, this is a response variable and I want to predict it. They think in terms of like, oh, I want to identify when a customer service incident is a known issue and cut down on time to resolution or something like that, which isn't quite aligned with what you sort of learn from the academic technique. So you spend a lot of time sort of with hands in both worlds and trying to figure out how to coordinate between them and bring them together. And oftentimes what you're doing, it's less about finding the best model with the best performance, which again, when you get formal data science training, that's kind of where the focus is, and more about taking complicated real world data sets and also requests from people with business knowledge and kind of shaping all those things in a way that you can sort of apply modeling to them at all. And that's a lot of times the success, right? Not that I made the fanciest model with the best performance, but I figured out the way to get modeling to even apply to a business context that wasn't really built for modeling in the first place. That is all I have. Thanks everyone for listening, and I will open it up to questions for the rest of the time.
Perfect. Thanks so much, Chris. If you want to throw that to the first slide, and we can just kind of have you answer against kind of the backdrop of your first slide. But I've got a list of questions here. DS3 students, if you have more questions, feel free to send them in. But I'll start with this first one. What made you interested in data science? It seems like it was a relatively big pivot from philosophy. What really drew you to data science in the first place?
Well, I guess partly it's just because I've always liked numbers and math, and I remember when I was undergrad, I majored in math and philosophy, and it was kind of I was pulled almost equally strongly in both directions. I guess I went a little more strongly in the direction of philosophy, but I always liked numbers and I always liked math, and I wanted to go back and work more with that. And I just really wanted to work more with technology, as teaching philosophy in universities. Like, I spent a lot of time standing in front of classrooms, lecturing about, great historical works of philosophy and so forth. And, you can try to fight against it, but the reality is students are spending lots of time looking into laptops or looking into phones or whatever. And it's just obvious everything in the world is sort of revolving around technology. And I just felt like that's kind of the most important thing in the world we live in nowadays and the time we live in. And so I wanted a job that was more connected to technology. So those two things together, plus just the opportunity. I lived in North Carolina, and there was a really great master's program at North Carolina State that was very easy for me to transition into. So, that as well. So those two interests, math, technology, and the opportunity all came together, and I got into the field, and that's where I've been ever since.
How did you end up at Teradata, and kind of what is the culture at Teradata like? And do you like working for a company that kind of has a more mid-sized feel, or do you see any benefits as opposed to working at a huge kind of large corporation?
So the first question is, how did I get into Teradata? I just applied and I got in. So as I was concluding my master's program at NCSU, it was a very professionally oriented master's master's program. So it was really about kind of like getting people into jobs. And so I did lots and lots of applying for jobs all over the country and interviewing all over the country. It wasn't actually it wasn't very easy for me because from the point of view of someone hiring data scientists, they're not quite sure to expect from somebody who just transitioned out of philosophy into data science. And so it was a bit of a challenge to get job offers, even though I did get a few. But I got hired. The manager who originally hired me was somebody who had some connections to NCSU, the university I came from, so that made them interested in me. And I got the job. I got the interview. I did the interview, and I don't know why they decided they liked me, but they gave me the offer. And I was really interested in moving to a different part of the country, Southern California, where I'd never spent very much time, and so forth. And so I took it. And as I said before, technology is one of the things I was really interested in, and so it was great to come into a technology company. And then the other question was, how do I like working at Teradata? It being a mid-sized company. I don't have a lot of unfortunately I don't have a lot of experience to compare to, because all my prior job experience was like in academia, which is like just a whole different universe that works totally differently. So I haven't worked in companies that are all different sizes or anything like that. I think I definitely wouldn't want to work. Well, maybe not. I won't say never, but for now, I'm not interested in trying to work in some tiny startup or something like that, where it's like there's always this like vague danger the whole ship could just sink any day or something like that, right? If your investor funding, next round of funding or whatever doesn't come through. Maybe someday I'd be interested in that kind of thing, but for now, being in a company that's bigger than that is something I'm comfortable with, because you just have a basic job security that makes it easier to focus on just getting what you have to do done day to day. And now the downside to that is that you don't really you don't have as much creative control over what you do day to day, because there's a lot more bureaucracy and process and people to approve and so forth. And so there's pros and cons as well. And working in a bigger, I don't know, I wish I could say something about working in a company that's even like a lot bigger, but I don't really have experience working in a company that's a lot bigger. So I don't know, maybe someday I can try that out and see what that's like as well. I don't know, Teradata feels kind of big to me. We have offices worldwide, and like I said, about 10,000 employees. I know there's other companies that are bigger, but it's about the right size for me right now.
And that's perfect. Thanks for your answer. What are the most important skills you think students should have kind of coming into the field and working in industry? And are there any soft skills outside of kind of the more general ones like communication that you think students should work on?
Let's see. So just in general, what kind of skills you need? Okay, so you definitely need to be really good at coding, because you will spend lots of time writing lots of code, and you have to do it on tight deadlines and so forth. Math, I almost feel like math is a really good thing to have in the background. Like I don't know, day to day doesn't feel like you're using tons of math, at least to me. Like it's good to have it in the background and kind of know what's going on with things mathematically, but day to day, you don't really have to think about the math behind a random forest or a neural network that much. Day to day, you're just kind of importing it from a library or something and using it. So I don't want to say that's not an important skill, but just as a ranking, that's not as important day to day as coding. I think another good skill to have is sometimes people don't talk about it enough is visualization. It's just so incredibly useful to yourself when you're analyzing data and trying to understand it, and to when you're trying to show it to other people and get them to understand the importance of data, to be able to display it in a way that's very easy to see and understand and makes the point clear right away. And there's all these things you don't think about when you're just kind of hearing about it in a classroom that you run into immediately in in reality when you try to actually start visualizing real data. Like, for instance, outliers. Like, you make a scatter plot. It's like, oh, I'm going to see how all these two variables relate across all my different observations, and you just hit the scatter plot function on your data, and there's like one observation that's like 100 million miles away from all the others, and so you've got that one, and then everything else squished in the corner at the opposite corner, and it's just like, well, I can't see anything here, and now you got to figure out like how to deal with it, that kind of stuff. And so that's not a trivial skill at all, and one that's incredibly useful in my opinion, and sometimes is underrated. And then the other part of the question was about, or the more specific part was about soft skills. So yeah, I talked about communication a few times. So that's extremely important. There's no getting around that. I guess another one that just comes to mind is like, is just like empathy, right? Like understanding what other people that you're connected with in your job, what they, what their motivations are, what kind of pressures are on them, and what they're interested in, and sort of listening and thinking about it to try to provide something that's really, really helpful to them. I mentioned, like, a lot of times you're dealing with manager and business types who have, all these ideas or things they want to do with the data, and a lot of times, that those people are, at a certain, maybe they're above you because they're your manager, but then they have people above them and so forth, and that they're kind of motivated by a desire to show someone higher than them some kind of important value or innovation or something with this data that they work with. And sometimes maybe they can't like super clearly articulate exactly what they want, or they don't know exactly what you're able to offer because they don't have the training you have and so forth. And so just being able to kind of listen to what they say and then kind of go away and think like, okay, well, here's what I think they really want, or what I think they'll really like, or will really be satisfying to them in their situation, and make them happy, given the pressures that are on them and so forth, and being able to react to that, rather than just trying to follow the exact letter of what people tell you, which is often not productive because they don't know exactly what they want in the first place. I think that's really useful. So empathy would be my example of a soft skill, other than communication. That's I think is very important.
Great. How much do you interact with clients, and would you consider a data scientist to be a client-facing role?
Yeah, I don't know I don't know exactly what's packed into the word client there. So there's lots of different, as I mentioned, it's a high variance job, and there's lots of different types of jobs. So I guess one kind of distinction I didn't bring out is there's a whole world of data science consulting jobs out there, which is really clearly and unambiguously a client-facing type of role. What are some companies there? Like, I don't know, Booz Allen Hamilton, I don't know, comes to mind. There's one that called like Cognizant. Once upon a time, I knew a lot of these consulting companies. There's a lot of consulting companies. EY is another one that have large data science practices. And in fact, even Teradata has some data science consulting. It's not a part I've ever really interacted with that much, but they have some data science consulting. I think, now I'm thinking of companies that do it, and I want to name them all, but don't worry about that. So there's data science consulting, which is a whole world out there that I haven't been part of, where basically what you do is, you get a contract that maybe goes 6 months or something. You fly out to the site of the client. They They tell you, they explain their data, they tell you what they want, and you got 6 months to make some kind of a model or a clustering of the data or something that satisfies what they want. And you put together a PowerPoint presentation to show them kind of at the end, and hopefully they're happy and they say you're successful and so forth. And so that's not a part of the data science world I've ever directly been a part of, except maybe a little bit kind of in a play acting way as a student. But there's a whole world of that kind of thing. I'm in a role that's more really kind of an internal role within a company that does something else besides consulting. I'm helping to make a product that the company uses to make itself more efficient, and so forth. So I'm really not interacting directly with like the customers of Teradata, but in a way there are internal customers of the product that we're making, because we're helping to automate part of the customer service process, and there's a broader organization within Teradata that controls customer service, and they're going to use our product to make their life easier, ideally. And so we have to be in regular communication with those people to make sure that we're meeting their needs and satisfying their needs and so forth. And so to make that a little more concrete, a big part of my job is meeting with subject matter experts, who are the people who traditionally resolve the customer service incidents. And they know, these are like some of the people who know a lot about the data, and they know a lot about what's going on in the business area. And they provide just a kind of like explanation of like, look, here's what it means when this error message is in a customer service incident, and here's how you figure out which knowledge article to recommend in that kind of case, at least the traditional manual way, which isn't always the way a machine learning algorithm does it, but you still need to kind of understand it. And then we try to build, like the next version of SAM, and then we kind of show them, or we even deploy it, and they get to spend some time seeing what it's doing. And then they can say, okay, well, this is good, but this is bad, and here's how you need to improve it. And it's important to them because that makes their job easier if SAM can automate part of it. So even in an internal facing kind of role like I have, you're still dealing with people who are using what you're making day to day and are not themselves data scientists. And so in that regard, it's really hard to get away from some kind of client facing character to data science roles.
And we've just got a couple more questions here, Chris. We'll do two last ones.
Okay.
How often do the technologies you use change, and how do you implement new technologies into the current stack you have? Do you try to integrate it if you believe it will become obsolete in a few years?
Oh, okay. Yeah, that's kind of that's a little bit more on the software engineering side, which is not quite right dead center of what I deal with day to day, but I'll still take a crack at it. So first question was, how often does the technology use change? I personally haven't experienced big changes in technology use. I've only been in data science like 4 years now, so I don't know if that's a big enough time frame. But I've pretty much been using Python, Python, Teradata SQL, which is sort of Teradata, SQL for Teradata. What else have I used a lot of Tableau, which is a visualization platform, a while back. Those are sort of the main things I've been using, and those haven't fundamentally changed. Python, I guess there was we switched from like Python version 2.7 to version 3 point something for people who know about Python a while back. That caused a little bit of headaches, because some things break from before and so forth. Didn't use Jupyter notebooks from the beginning. Started a few years ago, and there was some sort of learning curve on that. Sometimes we'll upgrade like a version of a Python library or something like that, and then there's a little bit of trouble because the old code breaks and you have to kind of go back and redo it and so forth. But I haven't really experienced really big technology changes since I started, but it's only about 4 years. And then the other question was, do you integrate something if it's going to be obsolete in a few years? Um, well, yeah, I don't know. Common sense says, let's see, if it's going to be obsolete in a few years. Yeah, that's kind of a long time frame, and agile uh, agile technology company kind of world. If you think it's going to be really used, I mean, who know, I mean, maybe everything's going to be, or maybe a lot of things are going to be obsolete in a few years. So it always depends on the cost, but I don't know. In general, if you think something's going to give you a large bang for the buck, I think, yeah, you would generally probably want to try to integrate it. It's only going to be a few weeks, maybe not, but yeah, a few years can be kind of a long time frame. It's sort of an agile kind of setting. Okay, so that may not have been the best answer because that's not quite my what I deal with directly day to day, but that's kind of what I've experienced.
That's okay. And for our last question, do you have any advice for students who are trying to seek a first-time data science internship, or if they're trying to get into kind of the field? I don't know if it necessarily has to be in this current job climate if you want to touch on that, but just any kind of general advice you have for people trying to get into the field, whether that be an internship or a job.
Yeah. So I guess um, two things that um, I guess a few things come to mind. So the first one is this is a nice question to end on because I get to repeat one of the themes of the talk, which is try to gather lots of information from lots of different sources. So don't pick one person who seems knowledgeable about data science and try to rely on them for everything. Try to learn a lot from different people, from who have had experiences. It could be people you meet and you talk to. It could just be people who write about the field online or something like that, and try to kind of try to see like which themes and which skills, which technologies, which patterns and so forth are common and emerging again and again to decide what to focus on. So that's one piece of advice. You try to get a varied diet of information about the field. Another one is, I know this is kind of a point I'm sure everyone's heard over and over again, is that networking is very, very important. So since I guess everyone's part of the Data Science Student Society, I presume that organization provides opportunities for networking with people in industry, and so you really want to try to take advantage of those opportunities as much as you can, because job postings come out. The company that posts a job, they always get lots and lots of applications, and it's somewhat overwhelming just kind of go through them and decide who to kind of shortlist and so forth. And so knowing somebody when you apply can really help cut through some of the initial red tape. Another piece of advice, I don't think any of this is really like groundbreaking or extremely or like news to anybody that much, is personal projects that you can showcase. Any kind of analytic project you can sort of do on your own and showcase on GitHub or at some environment like that, and just provide a link to it on a resume or a cover letter that people can go and just check out and see what you're all about, is a really great way to move ahead in your efforts to move into a data science sort of job. And certainly internships are a great way to get started, right? It's sort of lower pressure for everyone, both the person doing it and the company hiring for it because there's a lot less commitment there. And so I certainly would encourage anyone interested in moving into this field to try to do it via an internship. We do traditionally do data science internships at Teradata. I've mentored some interns in past years and so forth. And so that's extremely common and a great way for people to get started in the field. I think as Jarrett kind of briefly alluded to, right now everything is kind of topsy-turvy and upside down, so I couldn't even speak to what opportunities there may or may not be for it at the moment. But yeah, I certainly wouldn't want anyone to think that you can just sort of skip internships or not pay attention to them. They're really, really important to do. So to recap, get a varied diet of information, networking, personal projects to showcase what you've done, and really, look into to internships a lot. And then I guess finally, one last point is, find something to do within data science, because it's a huge field, and the techniques you can do, the types of data sets and projects you can work on. Find something to do that you really just enjoy and find interesting and get excited about. Because if you get into a mindset where I'm doing a project, I'm doing a neural network to forecast stock market prices or something like that, just because you think that's where a lot of good jobs are or something like that. But if you find that incredibly boring, it's not going to work out nearly as well for you in the long term to try to make yourself do lots and lots of work, doing some personal project on something you find boring or something like that, as working on something you find, really, really interesting. And if you're in an interview, for instance, which is obviously something you want to be preparing for, having, enthusiasm for something you've done that you love that's really important and interesting to you is going to be a lot better than talking about something you did just because you thought it was the right box to check to get a certain kind of job, but you don't really care about it that much and it's not that interesting to you. That kind of difference in energy will really show through in interviews and make a big difference. Okay, that's it. I'll wrap it up.
And on that note, I think that's a great place to wrap up. Thank you again, Chris and DS3, for collaborating with us on this series. We're going to work on getting this video out to all of the registrants pretty much right after this is wrapped up. And then we're also going to be putting it on our YouTube page. So I'll pass that on to Sravia and Sruthi, and she can kind of, and they can get it to you afterwards in case any DS3 students weren't able to make it today. Thank you again, everybody, for coming. Thank you again, Chris and Teradata, for helping us out today. And again, if you have any ideas for events or topics that you'd like to hear more on, please feel free to email me at jarett.hartman@techsd.org. Thank you very much again, and have a great day. Goodbye.
Jarrett, thanks everybody. Bye.
If there's still people on, just so you know, you will get an email with a playback as soon as the video is done editing.